All right, 3 for the parallel circuit. Hopefully you're doing this on your own first before you watch me do it. Okay, so I'm going to start with the schematic. And I'm going to go ahead and put the voltage circles in. Okay, you can fill them in either here or on the other picture as in Miss Medrano's videos. That's fine. Either way is okay, whatever you like. And I'll put another ammeter down there. Okay, so here goes our circuit. So I can see that I have 2 resistors, 2 light bulbs, one with twice the resistance of the other, are connected with a 9-volt battery in parallel. The total current in the circuit is 3 amps. Okay, so this one's a touch trickier. So the total current they're giving is 3 amps, and the battery is 9 volts. So let's go ahead and fill this in. That's 9 and 0. And remember, the key is carry this 0 all the way around, until you get a resistor. Okay, and then carry the 9 all the way around till you get a resistor. All right, this is going to be 3 amps. This is going to be 3 amps. Okay, all right, and the only thing it's telling me is that one resistor has twice the resistance of the other one. So that's a little bit tricky in this case. All right, but what I can see here, 9 volts to 0 volts, 9 volts to 0 volts, all of these are having a 9-volt drop. Okay? All right? And that's basically all we've got, all right, which is a little bit problematic. Okay? All right, so remember V equals I times R. All right, so here if I see 9 volts equals 3 amps times, this is going to be 3 ohms. Okay? And one resistor has to be twice the resistance of the other one, okay? Now, be careful. This is not a series circuit, right? So you cannot just add them together. This does not work because this is not a series circuit, all right? It's a parallel circuit, all right? So we have to think in terms of the current, all right? So when the current's coming around here, some is going to go down one path and some is going to go down the other path, okay? And then they'll join back together here at the bottom, all right? So if one path is twice as difficult as the other one, then the current is actually what's going to split 2 and 1, okay? So 2 amps of current will go one way, 1 amp will go the other way, okay? And we really don't know which is which, and it doesn't really matter, all right? Because I know that the currents have to add to the total, okay? So 2 plus 1 has to be 3, all right? And I know that they're going to split this way because one path they said is twice as hard as the other path. All right. So the path where more current goes is going to be an easier path to travel on. All right. Okay. So 9 here. 9 equals 2 times something. So this is going to have to be 4.5. Okay. And then 9 equals 1 times something, so that's going to have to be 9. Okay, so remember, these 2 bigger resistors are always going to make something smaller, right? Because in parallel, the resistance is going to go down, all right? And if you want to be really tricky, you can use this equation to figure it out. Okay, so it'd basically be 1/3 equals 1 over 4/5 plus 1 over 9, okay? And you'd be solving for that. Okay, but you don't have to do this. This is optional. This is like an extra step. Okay, all right, so let's go ahead and do the circuit. So I'm just going to put letters around each resistor. So this path we're going to call, I don't even want to put it there, C to D, and then I'm going to call this C prime D prime, or C1 D1, however you want to do it. Okay, so I'm just going to be A, B, C, D, and back to A. All right, and I'm going to go up to 9 volts, okay? From B to C, we're going to cross, and then the drop happens from C to D, okay? But there's also another path, the C prime to D prime path, so it's going to be like this. All right, and then they're going to come back together, okay? So here I should see 2 paths. Right? One is on the first branch, one is on the second branch, but they're both a 9-volt drop. I think that is it.